Welcome, everyone. We'll just give a couple of minutes to let everyone join. So good morning, good afternoon, good evening, everyone. Welcome once again to today's EPI-WIN webinar on the attributes of pathogen genomic data platforms supporting timely and equitable sharing. Thank you particularly to those of you from far away where it's late at night or early in the morning. For those of you who are new to EPI-WIN, it stands for the WHO Information Network for Epidemics, and we aim to make the science behind the work that we do accessible, actionable for evidence-informed actions and policies. So we're very, very happy that you're here with us today. Please introduce yourself in the chat and tell us where you're from and what you do. And if you have any insights that you'd like to share, please do share it in the chat. But if you have questions for today, please put it in the Q&A box so that we can respond to it faster. This webinar is being recorded, and we have a very exciting panel today to talk to you about pathogen genomic data platforms. You can see the agenda. We have the opening remarks by Maria van Kerkhoff, Director for Epidemic and Pandemic Management. She's no stranger to EPI-WIN, and indeed, I'm sure she's familiar to most of you. Then we have the overview of the document by Dr. Lorenzo Subisi, Technical Officer, and Dr. Sylvia Argimont, Senior Technical Advisor for Public Health Lab Innovation Platforms at the WHO Hub in Berlin. After that, we'll have the Q&A moderated by Greg Armstrong of the Task Force for Global Health and Caxton Murira from the Science for Africa Foundation. The panelists that will be answering your questions and other questions will be Eddie Kinganda Lusamaki from the Institut National de Recherche Biomedical, Guy Cochrane of the Global Biodata Coalition, and Torsten Semmler from the Robert Koch Institute. We will then have closing remarks by Dr. Oliver Morgan, who's the head of office for WHO Hub for Pandemic and Epidemic Intelligence. But without further ado now, I would like to invite Dr. Maria van Kerkhoff to give the opening remarks. Over to you, Maria.
Thank you so much, Supriya, and good morning, good afternoon, good evening, everyone. Thank you so much for joining this EPI-WIN seminar organized by the WHO Health Emergency Preparedness and Response Program. I am really thrilled to be here today with my colleagues from across the program and our partners to discuss a very important piece of work that we've been involved in for the past couple of years: attributes of pathogen genomic data platforms supporting timely and equitable sharing. This is something that we initially began working on as a project with the UKHSA, and have also had the support of the International Pathogen Surveillance Network, who you will hear from during the panel. Why this is so important to all of us is because it is so critical that genetic data and the sharing of genetic data through these different platforms contribute to the work that we all do on epidemic and pandemic prevention and response. I'll give you one example specifically on COVID-19, but a few others, and then you'll hear more about the importance of sequence information and the platforms and the work that we do. As a remember, on the 31st of December 2019, WHO received the first reports of a cluster of pneumonia, 27 cases of pneumonia of unknown etiology from Wuhan, China. Within less than 2 weeks, On January 10th, 2020, WHO had already published its first laboratory guidance, and the first SARS-CoV-2 genome sequence was released. 2 days later, one of the WHO reference laboratories, the University of Bonn, developed the first RT-PCR protocol, working together with several WHO laboratories that worked on coronaviruses across the world, followed by WHO-validated diagnostic protocols. This led to our ability to work with manufacturers, and by early February 2020, WHO was able to distribute diagnostic test kits to 159 laboratories worldwide. And only 11 months later, the first mRNA vaccines were authorized, enabling vaccination campaigns to start across the world. This unprecedented speed was driven by rapid and open sharing of early data, including genomic sequence information. Throughout the pandemic, early data sharing enabled by WHO with the Technical Advisory Group for Virus Evolution, or TAGVE, worked to rapidly identify and alert the world to emerging variants such as Alpha, Beta, Delta, Gamma, and Omicron. For Omicron, the first sequence was publicly shared by South Africa on the 24th of November 2021, and within 2 days, WHO designated this a variant of concern. Today, the largest genomic repository for respiratory viruses, or GISAID, hosts over 17.5 million SARS-CoV-2 sequences. Another example is the recent Ebola outbreak in the DRC. The National Institute for Biomedical Research, INRB, which is the National Reference Lab, took less than 24 hours to generate and publicly share their analysis of sequence data since the samples were received in the lab. WHO, our member states, and our partners are responding to many outbreaks such as Mpox, Rift Valley fever, Marburg, Ebola, cholera, diphtheria, and many more. And pathogen genomics are a key aspect to outbreak response. In March 2022, WHO released the Global Genomic Surveillance Strategy for 2022 to 2032, which includes strengthening data sharing for timely public health action as a key objective. Multiple pathogen genomic repositories exist, each differing in data types, metadata requirements, access policies, and curation practices. As I mentioned, we started development of this particular document looking at the attributes of these databases, first with the UKHSA, and this work was further refined by the experts from the International Pathogen Surveillance Network, or IPSN. This document outlines key attributes of effective pathogen genomic data sharing platforms. This is so critical so that we can build trust and facilitate trust, sharing of information between member states, between academic and research institution and manufacturers, so that all can feel safe in sharing this data, which is meant to be shared in a timely manner for public health action. I thank all of our panelists for speaking with us today. Thanks so much to my colleagues in the WHO Berlin Hub, which is part of the WHO Emergencies Program as well, and to all of you for joining. Wishing you a great seminar. Back to you, Supriya.
Thank you so much, Maria. And now, before we go to the technical part of things, we'd like to hear from the participants, and we'd like to know a little bit more about you. So we have a Slido here, as those of you who know EPI-WIN are familiar with this. We have two questions for you today. The first question is, can you see this? Have you or your organization uploaded pathogen genomic data on international publicly accessible databases? Okay, so we've got 51 responses, 54 now, and most of you seem to have uploaded to multiple pathogens. Yeah, like a few more responses before going to the next question. Okay, now we have another question for you. Have you or your organization downloaded pathogen genomic data from international publicly accessible database? The first was on uploading data, and this is on downloading data. Please respond to the Slido. It's at slido.com, hashtag 6923124. I can see many of you are responding on the chat, but please go to the Slido and respond. Slido.com, hashtag 6923124. Right. Okay, it looks like we'll stop here, but I will leave the Slido open for your responses. It looks like most of you have both uploaded and downloaded multiple pathogens. And with that, I would like to invite Dr. Lorenzo Subisi to give the first part of the presentation on the overview of this document. Over to you, Lorenzo.
Thank you, Supriya. Good morning, good afternoon, good evening, everybody. Okay, I see Kanika is going to share the slides. Thank you so much, Kanika. So, yeah, I think next slide. I think it's great to have this seminar where we're going to discuss a little bit on why we have come up with this document. So I think it's important to start with the context. As Maria mentioned during her speech in 2022, after the huge global increase in pathogen genomics, in pathogen sequencing triggered by the COVID-19 pandemic, the WHO launched a new 10-year global strategy to improve genomic surveillance, which is the use of genetic information to track diseases. And that strategy had four key objectives. Improve access to genomic tools so that all regions of the world are better represented, build strong workforce that can generate results quickly and with high quality, improve connection between countries and systems so genomic data support the bigger public health surveillance picture and keeps the world ready for emergencies. And then the last objective, strengthen data sharing so that information can guide both local and public health action. I think in regards to the latter, I would like to stress, next slide, I would like to stress why data sharing matters so much. Data sharing really is essential for public health as it allows early detection of outbreak, new variants, and changing trends, a faster development of medical countermeasures such as diagnostic tests, vaccines, and treatments, and quicker and better public health responses. So when countries don't share data or where there are no shared standards and principles for sharing those data, there are issues that arise. Some like information becomes siloed, there are delays, and there is poor quality in those data. So I think this really limits its usefulness and reduces the trust. So, of course, WHO is committed and strongly support equity and capacity development so that all countries, not just a few, can contribute to and benefit from genomic surveillance. So, as an example, during COVID-19, as mentioned by Maria, early data sharing has allowed quick development of diagnostic test protocol for member states to use within days from the first release of the SARS-CoV-2 sequence, and also there was the quickest development in history of a vaccine that took 11 months from the first sequence data to vaccine regulatory approval and rollout. However, I think inconsistent data governance system and unclear rules about rights and responsibilities for data submitters and data users sometimes have discouraged people from sharing. So next slide. So this is the slides about the timeline, the example of COVID-19. So let me go to the next slides. Yeah, and so I think that's where the need for this document comes from. And that this document really aims at building consensus within the scientific community through the International Pathogen Surveillance Network that you are all familiar with on what good practice looks like for pathogen genomic data sharing platforms, and also defines key attributes and guiding principles for system data and governance. Of course, the other key element is to help strengthen trust, improve interoperability, promote equity, and increase impact. Next slide. So I think really what was the aim of the document? To define attributes, so the essential feature that data sharing platforms should have, define principles, the operational features, how data and systems should be governed and shared, and provide a shared language and framework so that stakeholders can align on expectation and implementation. So with that, I'd like to give the floor to Dr. Argimon for the rest of the presentation. Thank you.
Thank you, Lorenzo. And again, hello, everybody. Good morning, afternoon, or evening, wherever you are. So thanks, Lorenzo, for providing a background to this document. If we go to the next slide, please. I'd like to mention before we jump straight into the content of the document that the document targets different stakeholders involved in the data sharing process. The platform users, such as those generating, uploading, managing, or downloading data, can use this document as a foundation on key technical, governance, and ethical aspects of these platforms. Whereas platform developers and managers may use it as a guide to develop existing platforms or to design new ones. Meanwhile, funding organizations can use it to set expectations, plan investments, monitor progress, and support capacity building. And more broadly, for policy, this document can inform data sharing agreements and partnerships, for example. Next slide, please. Yes, thank you. So the framework of attributes and principles is underpinned by 4 objectives of platforms that support the broader public health community in protecting the population from infectious threats. And these 4 objectives are to encourage data sharing through a secure, transparent, accountable, equitable, and sustainable approach to the storage of pathogen genomic data and linked metadata. To facilitate rapid sharing, so that's the timely sharing, of pathogen genomic data and metadata through a range of data submission options with different user interfaces and network bandwidth, so that we are catering to different users. To facilitate analysis and a public health informatics ecosystem to gain further insights from the data. And last but not least, to support collaboration and the formation of a community of practice. Next slide, please. So linked to these 4 objectives, the document then defines 12 attributes of pathogen genomic data sharing platforms. Governance, which is the management structure that provides oversight of the platform and ensures that it operates in a manner that is consistent with applicable laws, regulations, and norms. Transparency, which can be demonstrated in different ways, for example, through documentation of funding sources, documentation of the sources of data, and also an auditable trail of changes. Infrastructure and security are the combined measures that protect the data from unauthorized access, loss, or corruption, whether it's from accidental use or misuse or malicious action. The data scope refers to the scope and nature of genomic data and metadata. For example, the pathogens included in the platform and the data types included, such as raw sequence data, genome assemblies, or metagenomes. Data submission describes the methods available for data uploads, such as manual and automated uploads. Data curation describes the methods available for, describes the data integrity, quality, and completeness checks that are performed to the data and metadata to ensure that that data is of high quality. Data provenance it refers to the auditable trail of information back to the generator of the sequence data. So for example, linking that data to the sequencing lab. Access describes different models for platform users to browse and retrieve data and metadata with attention to any potential restrictions to that access or charges. Interoperability means the automated access and exchange of information between different computer systems with minimal intervention from users, from humans, basically. And data use and benefits sharing describes the frameworks needed to define the user's rights and responsibilities, how the data can be reused, and the expectations for the benefits derived from that data. Analytic and reporting capabilities outlines good practice for analytical tools that make it possible for the users to query and retrieve data. And lastly, sustainability, which refers to the operational continuity and long-term preservation of the data. So linked to each of these 12 attributes, the document then defines between 3 to 10 operational principles for a total of 54 principles. But in the interest of time, I will just show you an example for attribute number 10. Next slide, please. Which is data use and benefits sharing. So these attribute encompasses 4 operational principles: the user code of practice that defines the rights and responsibilities of users, the consequences of any violations, and the contesting or appealing procedures. The data license that specifies what the platform users can do with the data. So for example, whether they can do onward sharing or not. The mechanisms to ensure compliance with the code of practice and the data license, which should be in place, but also public, and a benefits sharing framework that sets expectations for different benefit sharing opportunities. Next slide, please. And we mentioned before that these principles are part of ongoing work at WHO to enhance and promote better data sharing. And one of these were the 2022 Guiding Principles for Pathogen Genomic Data Sharing. And so these document operationalizes these guiding principles specifically for the platforms. And to show you an example, Guiding Principle 3 recognizes the importance of high-quality, reproducible data. And in this document, this is reflected in data curation, attribute 6, which states that there is a publicly accessible policy on data curation practices covering criteria and thresholds, and which processes are applied to the data. And this ensures that the fact that this policy is not only in place, but it is public, ensures that users can understand what filters and thresholds are applied to the data, and this facilitates both data quality and reproducibility. But next slide, please, or next click. At the same time, the 2022 Guiding Principles recognize that during emergencies, there is often a trade-off between sharing data quickly and sharing high-quality data. So this document contains Principle 6.3 that specifies an option to submit low-quality or incomplete data and metadata. Nevertheless, the goal was not to establish a one-to-one relationship between the two documents, but more broadly to capture the consensus views and opinions of the pathogen genomics community with regards to data sharing platforms. Next slide, please. So as Maria mentioned, the initial framework was developed in collaboration with experts from UK HSA and a few other organizations by commission of WHO, and contained 10 attributes and 28 principles. This draft document, next please, was then developed and consulted with a larger group of experts, representatives of different countries and all WHO regions. And the framework grew to 11 attributes and 43 principles. Next. And this draft was then shared for public consultation, during which we received 45 unique responses representing 23 countries. And the responses were analyzed to identify topics raised by at least 2 respondents. And again, the document underwent a new consultation with the expert group, and the final framework grew to 12 attributes and 54 principles. And this is what, next slide, please, next click. This is what we published about a month ago, and seen as of last Friday, 722 people had downloaded this document in the first month that it's been out there. So we hope that if you generate or use pathogen genomic data, that you do so with these principles in mind, and also that you advocate for their implementation. And I would like to finish, next slide, please, by acknowledging everyone and expressing our deep appreciation for everyone that contributed to the development of this document, including the respondents to the public consultation and the members of the IPSN community of practice on data. And of course, thank you for your attention. And now I'm delighted to hand over to the panel moderators, Greg Armstrong and Caxton Murita, who will be leading an interesting discussion and the Q&A.
Thank you, Sylvia. So I'm Greg Armstrong for the Task Force for Global Health, and together with Caxton Murita from the Science for Africa Foundation, we host a forum for funders of pathogen genomics. We have 3 panelists today. In the interest of time, I'm going to ask each of them to introduce themselves after I ask them the first questions. Our first panelist is Eddie Lusomaki from INRB in Democratic Republic of Congo. Dr. Lusomaki, so your organization, INRB, has been at the center, really, of a lot of important public health emergencies in the recent past, and it's been very active in sharing and using genomic data. Let me ask you from your perspective at INRB in DRC, how can this document inform your strategy and your practices around data sharing? And are there particular parts of it that are particularly resonant or particularly important with you? And again, please start by introducing yourself.
Yeah, thanks a lot, Greg, and thanks to the presenters for giving this clear presentation on the document. I'm Eddie Lusomaki from INRB in DRC in Kinshasa. And also, I'm a medical doctor by training, and I had a PhD here in Montpellier in France. I'm also hosting a postdoc position in the IRD. So to come back to the question, at INRB, we are really committed and aligned to rapid data sharing, given first the position of DRC in the Central Africa, sharing borders with 9 countries, and also given the high frequency of disease and notification. And that's why we are really committed to reply the quickest possible and to get also all the community attention, because a problem that we have in one part of the planet can still reach the other part of the planet, as we've seen with COVID-19. And this document tries to illustrate somehow the experience we've gone through different years. I think we can say up to 7 years to the genomic data generation and sharing with that with many Ebola outbreaks and also with Mpox. And for us, I think when we look at this document, and also as Sylvia presented, that it's really important to make the data generators confident and secure, to encourage them to share the quickest. And I think putting in place some measures to show how to develop those platforms, it's really important, and it makes it really transparent to everyone on how to handle genomic data. Over to you.
Thanks. And so, and the other question I wanted to ask was about travel restrictions. This has been one of the challenges in data sharing, and I know it's hit Africa particularly hard at times during the pandemic. I was wondering if you could talk a little bit about that, about the risks involved in data sharing and the risk of incurring travel restrictions or other restrictions.
Yes, I think one of the sad experience that we had was during COVID-19, and we've seen how the publication of some results or variants which were circulating in one country led many other countries to put in place measures to restrict travel. So the big metaphor or comparison I can use for such situation is like in medicine, as we are trying to make sure that there are no stigma for patients living with HIV or Mpox. We are encouraging them to reach the hospitals and then to be cured without any stigma. And we should have the same way of thinking when it comes to countries reporting the disease. So we really need to be into a community when we feel secure when it comes to sharing that. And I think for that, the platforms should not be the one delivering the information or the analytic. I think this should be given to people and agencies which are, because interpreting data, genomic data, is really a big deal. It's not always easier. We need to put the data into a context, and we also need to do that in a way in which other stakeholders are also parts of that interpretation. So pushing out the great information out of great and high quality data, I think it's the most better thing to do. And that relies to some of the attributes that were developed, like data curation, like the access, who should have access to the data, like the analytical parts, and so on. So to summarize, I think that's my view and my thinking on such situation. We should really put people to conditions where they are committed to share their data and protect them.
Yes, thank you very much. You know, you bring up the issue of the context of the data, and that brings us to the next speaker, Guy Cochran of the Global Biodata Coalition. Dr. Cochran, you know, your organization has done a lot of very interesting work in defining issues around sustainability and interoperability of these systems, because of course, you know, what we're looking at today is you know, specifically pathogen genomic data. It fits in a much larger ecosystem. I was wondering if you could comment about that.
Yeah, sure. Well, hello to everyone on the call, and thank you for giving the opportunity for me to sit on this panel. Yeah, so Guy Cochran, I'm the Executive Director of the Global Biodata Coalition. So the GBC, the Global Biodata Coalition, is a coming together of funding organizations that fund life sciences and biomedical research. And they understand together the importance of databases in the everyday work of scientists, and that's scientists working across many different domains within the life sciences, but of course it includes public health, it includes research into infectious disease, it includes food chain work, One Health, and a host of other things as well. And as you say, Greg, it's a continuum, it's an ecosystem, and so the databases exist. There are several thousand databases that exist around the world that are useful to scientists, and it's for the most heavily used, there are hits on those databases every few seconds. So this is a really important part of the toolbox that a scientist has, and they're very important in progressing science. So the funders come together, they recognize the importance, but they recognize that there's some fragility in the system because it's a system that emerges. People build databases and they offer them up for use. There's no top-down plan, and there's not even an overall list of what the databases are. So it's an emerging system, but with that comes some fragility, and so the funders recognize that in order for the research programs to continue, for the science to progress, they need to be sure that the key functions of this ecosystem of databases are continued. Not just in the current state, but the whole system is able to adapt to new requirements. So when new requirements come along to cover new pathogens, new disease mechanisms, for example, the system needs to adapt. So the GBC has done quite a bit of work in this area. A lot of our work is about understanding the databases and characterizing the extent to which they're integrated, where data flows from one data resource to another data resource. So as a part of that, we know, for example, we estimate that there are 750 databases that have some relevance to infectious disease research or to pathogens, covering different data types, many of them genomics, many of them other data types. Those 750 can sometimes be very specialist, dedicated to a particular pathogen or a disease, but sometimes they're generalists. They have some content and some tools of interest to people working on infectious disease, but they're not necessarily focusing on that. But amongst those 750, we estimate there are 150 that are pulling data. They don't accept data. They're working on genomics, but they don't accept data directly as submissions. They pull data from a data repository where people provide their data, and they add value. They curate, they run analysis, they provide tools, and so on. So it's a very interconnected, interoperating, and integrated system of databases. So part of the work of GBC is to try to characterize that. Part of that is that we run a program called the Global Core Biodata Resource Program, which invites people who run databases to come to us and to apply for the Global Core status, which is an external expert review against a set of criteria that define the level of professionalism, the value to the community, the inclusion of standards, and so on in the data resource. And we have currently a group of 52 such databases. And we can work with the leaders of those databases to understand sustainability and to further sustainability. Early this year, working more with the funders, we developed a white paper and a consultation process that came up with some principles about how funders could work better together to sustain and add value to this ecosystem of databases, and came up with a number of models. We're moving into the next phase of GBC where we're beginning to explore those models. And we hope soon to be starting some pilot studies where we invite some of the data resources to take steps towards greater sustainability, to reorganize or to rework things, and work with the funders for more coordination to ensure that they can continue to provide what's useful now, but continue to grow and continue to offer what will be useful in the future.
Great, thank you very much. That was an excellent summary. Let me hand things over to my colleague, Kaksimir.
Yeah, thank you so much, Greg, and to our presenters earlier on. So my question is to Thorsten Simler from the Robert Koch Institute in Germany. Different audience, some of them funders and some of them policy and governance related. And we do know in terms of responding to public health, infectious diseases and non-communicable diseases responses. So, from a political perspective, how can this document inform, utility?
Well, I think I have not got everything, but I think the key message I got, this is Thorsten Semmler from Robert Koch Institute, Germany's National Public Health Institute. And here I'm as the head of the recently formed Genomic Surveillance Unit. Thank you that I have the possibility to be here on the panel. So one of the questions that I understood was how can this document help us here in regards of data sharing at the Robert Koch Institute. So actually, we have a strategy that we are following to establish a genomic surveillance in Germany, led by our institute. And also, the strategy not only includes pathogen genomic data sharing platforms, but everything that is around these platforms, so transport of data, analyzing data, and using the data for actions, is also associated with the same attributes that are relevant for these pathogen genomic data sharing platforms. So we use these catalogs, this document here, as a blueprint to check our technical and organizational design of the whole genomic strategy, genomic surveillance strategy. And some of the key points that I would like to mention here that are quite important for us. Meanwhile, we can use all of them, but for example, in the terms of data scope and metadata, here we clearly try to align our genomic surveillance that we establish at RKI with the global expectations. So at our IGS program, as we call our genomic surveillance program, we have a pathogen spanning system here covering bacterial and viral pathogens from lots of diseases from respiratory, foodborne, nosocomial, and sexual and via blood transferred infections. And we try to link the genomic data with epidemiological data that is reaching our institute through our national, so the German electronic reporting system for infection protection. And we have the list of pathogens that we have under this genomic surveillance that was already defined and will be constantly adjusted according to first our national needs, second consultations and recommendations from ECDC, and third also, of course, from recommendations from WHO. And here the WHO document emphasizes that pathogen genomic data should always be linked to rich standardized metadata, so like a time, place, host, sampling strategy, lab, bioinformatics methods, and so on, and with predefined optional fields for more detailed clinical and One Health information. And that is exactly what we aimed at the beginning from our genomic surveillance program, to not only collect genomic data, but to, from the beginning, bring it into the context with the other, we do not call it just metadata, it's actual contextual data that is itself already primary data, so the classical epidemiological data that can be used for analysis. And if they are linked to the genomic data from the patients, like age, sex, severity of infections, or existing co-infections, then that gets the genomic data much more significance. So these aspects from the points. And another point that I want to stress from the document is the sustainability. That's the same message that we have here also arguing with our funders, that genomic surveillance is intended as a permanent generic solution for infections disease surveillance. So it's not a project that can be time limited funded, but that has to be sustainable funded to generate its additional value. And this WHO text gives us and our ministry a very strong external reference to argue that the structural long-term funding is a requirement and not just nice to have. So that is there are two examples from the document that how we will use these thoughts that are very useful for us in this document in our daily work, not only for the data sharing platforms but for many related fields in the terms of genomic surveillance.
Great. Well, thank you very much. Let me jump back in. My colleague Caxton has been having some technical issues, but let me turn a set of questions to all of the panelists here. These actually come from the audience, and I'm just summarizing some of them here. This document is obviously quite complex. It has 12 principles, or 12 attributes and 58 principles. And there's already a lot of data systems out there, most of which don't comply with all of these. The question is this: so first of all, is it possible to prioritize among these? Are there some that are more important than others? And also, how can existing data systems come into alignment with this? So I don't know which of the panelists wants to start with this.
I could have a go with the second question more than the first, if that's okay.
Sure.
Yeah. So I think when a scientist or when a public health someone looking at surveillance data is working, they very rarely use a single database or a single platform. They work across multiple systems. And if the systems are interoperable and they comply with the same standards, then this is fruitful. This works. So I think it would be wrong to look at the attributes and principles document and expect a single platform to comply with everything and be the single solution for everyone to use. Rather, in different cases, people will choose different components, different component databases that together comply with or meet all of the criteria. So they follow the principles and they comply with the attributes. So that system needs some coordination. And I think for many of the existing platforms, the existing databases, there are some areas that trigger some immediate work. So in particular in data provenance, there isn't really as far as I know, a consistent standard about how you attribute different contributions. So to sampling, to risk analysis, to sample processing, to data generation, to data curation, and so on. So there's a whole chain of value add before you get to the shared data set. I think in the scholarly literature, there's been some effort to try to categorize and classify. And I think that probably hasn't happened systematically in the database world. So I think there's a piece of work that that can be taken on there. But I don't think that we should be looking for data combinations of data resources that work in different situations that comply that meet the principles. And I think it would be wrong to try to constrain people to a single system. And of course, because there are many different existing systems and they already have certain characteristics, there'll be some folk that will probably dictate how things develop over the next few years. So I think to the first question, I think if there is a priority for certain attributes to be dealt with first, then I think that will be useful to know. But I have a feeling that if you're adapting an existing system, it will naturally have its own priorities already.
Great, thank you very much, Dr. Lusumaki or Dr. Zemmler. Do you have anything to add to that?
Yes, I think everything is a matter of building on something which are already existing, because I think the existing databases were part of some efforts or initiatives that were put in place. So this is something that we can't erase. But with this document, I think this to help to improve things, because I think given the presentation that were given, the document came out of a need and given also some issues and challenges that we've been facing in this specific area of data sharing, and specifically for genomic data sharing. And the document is trying then to fix that. I think this is not to be done in one day, but this is something to accompany all the stakeholders within all those platforms and make sure that surely step by step we are moving towards to a more secure and with trust and we build with confidence to both users, data generators, and many other public health stakeholders and policy decision makers. So this is something that we really need to work on together as a community with every person with respect of its position and roles. Over.
And let me turn to Dr. Zemmler. And get back. We've been getting some questions about prioritization of the attributes in this document. Are there aspects of existing data systems that you use frequently that you think could use improvement, or particular attributes from the document that you think need to be emphasized more?
Well, yes. I mean, I can give the example for the SARS-CoV-2 data, where we had the decision to make where to submit the data. There were this big community of GIS8, so we had to push all the data there. But on the same time, we were, I mean, that was our obligation to put it in the European data space, where we have ENA as the repository of choice. And of course, as lots of funding sources come from there, we use that platform as well. And now we have this new Pathoplexus platform that is promising a lot. And our bioinformaticians like the ideas that they propose a lot. So, I mean, and we have heard from guys that there exist many more data platforms that might be relevant. So sometimes it's difficult for the people if they have to decide fast where to push the data, what makes lots of sense. So maybe we can use this document with these attributes to evaluate or let the database curators or owners themselves do a self-assessment against these 12 attributes, so that there can be easily some kind of checklist. What are the I mean the properties here of these databases, and how are they suited as pathogen genomic data sharing platforms?
Great. And we have time for maybe one more question and answer. Maybe I'll direct this back to Dr. Cochran. We've gotten a question about traceability of genomic data. You've talked a lot about the importance of interoperability of these systems. I guess the question is a very general question. How can we start to address this issue of traceability and making sure that anyway, I'll leave it at that.
Yeah, it's a really important question, and of course it depends how you define traceability. So having sufficient provenance information to understand how the system is working is really important, so that people can be credited for the contributions they make, so they have more buy-in to the system, and more value comes back to them from the system. But of course, if you put in place a very literal tracing back of some scientific or some public health observation or some piece of knowledge that's based on these data sets from these contributors, if you try to turn that into more of a contractual system, then the whole system slows down. One of the beauties of across these thousands of databases is that data flow very, very freely in most cases. So things are very open, and there are no obligations placed on a providing database for a consuming database to do anything. The minute you start to introduce measures to trace things in absolute terms, then you introduce friction in that system. So I worry that if you introduce a system that was that traced everything, then in minute detail, then you would end up with a system that's far less productive, and it doesn't produce the knowledge and the benefits that you'd like to get. So I think having an idea of where the data is provided from, where it's integrated, where it's useful. I think that's really important to show the value of the system. But I don't believe that having detailed absolute traceability is a requirement for benefit sharing. In fact, I think it runs counter to benefit sharing.
Great. Well, listen, I want to thank all of our panelists for this excellent panel, and also to all the participants who sent us in questions. And let me hand things back over to Berlin now. And I think Oliver.
Oh, thanks, Greg. The confusion comes, I'm actually sitting in Geneva today, so but thanks so much, and thanks again to all the panelists and presenters who gave us such a great EPI-WIN session today. And my name's Oliver Morgan. I'm the head of the WHO Hub for Pandemic and Epidemic Intelligence in Berlin. And I just wanted to say a few closing remarks for this session. And I think, as you heard, we started off in kind of 21, 22, thinking about the principles behind pathogen genomic data sharing, and developed a kind of a set of principles around that. And then, of course, that led to a conversation about how can we think about this from an implementation perspective. And as the previous conversation showed, that it's a very complicated environment with many different actors and actually many different objectives among those actors as well. And so the approach to establishing principles for data sharing platforms is a very pragmatic way forwards to help those organizations that are running pathogen sequencing data sharing platforms to adjust and to evolve their practice as well. And we're very grateful for all of the colleagues who have given input into that document through the open consultation that we ran in order to come up with those attributes. Of course, it's very timely, given the conversations happening around the pathogen access and benefits sharing component of the pandemic agreement. And this attributes document is really feeding into those conversations about how can we have a system which, as to maybe just use some of the language used by Guy, has minimal friction but maximum benefit. And so this is the challenge ahead of us. And as Eddie also mentioned, we're building on our past successes and continuing to build in a stepwise manner. So thank you very much for everybody's participation, both in the thinking, the design, the implementation of the documents, as well as our ongoing work together to identify how to use these attributes for the most benefit. Thank you very much. Am I handing it back to you, Greg, or to Supriya maybe?
Thanks very much, Oliver, and a huge thanks to, you can just see from the emojis that although this is a very specific topic, clearly it's been appreciated. So thank you, Oliver, for joining and giving the closing remarks. A huge thanks to all the speakers and the panelists, as there were some really interesting questions and quite pointed ones as well. And I think that was a really good discussion. A huge thanks to Sylvia and to Josephina and Timothy for organizing this webinar. I'd also like to thank everyone in the background, working in the background, WHO IT, my colleagues, Michael, Maria Isabella, Kanika Sachdeva from our WHO Collaborating Center, Project ECHO. And last but not least, all the participants, who taken this time out to share their views, ask their questions, and I hope to learn. So we actually have we don't usually have EPI-WINs on Mondays. This was exceptional. We will also have another EPI-WIN webinar on this Wednesday, which it will be on defining cases of meningococcal, let me see if I can share this right now. Defining cases of meningococcal disease, a public health tool for outbreak prevention and control. And can you see this? Is it being shared? So this is on Wednesday, and it would be great if all of you could join again on Wednesday. Thank you so much. And before we end, Sylvia, would you like to say anything?
No, I think Oliver already delivered excellent closing remarks. Thank you, Supriya.
Thank you so much. And thank you, Oliver, for the closing remarks. And with that, see you next Wednesday and next time for the genomics team.